Assuming that don't have any doubt, now we'll go to the last topic in our unit, which is seeing example for each amplifier, practical example. So far you have seen the theory, theoretical diagram, the theoretical RIF and R0F calculations. Now we'll close all the theory. Now we are going to see what is the practical example for an voltage series amplifier, voltage shunt amplifier, current series amplifier, and current shunt amplifier. Okay, and see here voltage series. First we'll take voltage series, and we have three examples in voltage series amplifier. One is BJT, common collector amplifier. It is called as emitter follower. The other name for common collector is emitter follower. Equivalent for common collector in to BJT in FET, we have common drain. That is called a source follower. And last one, voltage series feedback pair. So when I connect two amplifiers in cascade, that is going to be voltage series feedback pair. Okay, so first we need to understand. First we will go with BJT, common collector amplifier. See the diagram. Common collector, as the name indicates, common collector, input is going to be base and output is going to be emitter. And I should actually ground my collector, but if I ground my collector, the amplifier will not be biased to my Q point, so I will not ground my collector. I will be connecting VCC to my collector. So this is a common collector amplifier. See, when you do analysis, either the terminal should be grounded or it should be connected to a battery source. That is the requirement. So if I ground collector is the terminal where you give your biasing, right? So if I ground my collector, there is no point in operating my transistor. Okay, so I am not going to ground my collector, and I am going to connect load and VCC across my collector. So input is base current, input is going to be base terminal, output I'm going to take from the emitter terminal. Since I'm taking output from emitter, I cannot ground the emitter. I will be having an emitter resistance RE. If you ground the emitter, then V0 will be 0 because emitter is grounded to 0 potential. So since I'm going to take output from emitter, you cannot make direct ground with emitter. You have to connect an emitter resistance RE to collect output from the emitter side. So usually for any amplifier, we will be using common emitter configuration and output from collector, right? But here, since the example is common collector or emitter follower, you should take output only from emitter. Then the unique property of emitter follower is voltage gain is unity. There is no voltage gain provided by this amplifier. So whatever is the input, that is going to be the output. The voltage gain is unity. There is a very good current gain because output current is emitter current, input current is base current. You will have a very good current gain, but the voltage gain is unity. It is called as emitter follower because the output voltage is going to follow the voltage across the emitter follower. Okay, so remember this property. The voltage gain will be 1 for a, it will be approximate. Ideally it is 1, practically it will be less than 1.9, 0.95. It will be like that. So first we will see the basic thing, common collector configuration, or it is called as emitter follower.